Example 2 in 10.2 just introduces a little more complexity with the type of function this has. So right away, let's rewrite h of x and then determine what it is. So for part A here, I'm going to say that h of x is the function g of x divided by the function f of x, and then I'll actually put those functions in. So g of x is 2x plus 6, and f of x is x squared plus x minus 6. All right, that is the function h of x. There's nothing wrong with that. What I'd like to do though is fall back a little bit on our chapter 9 knowledge, and if we're really going to talk about h of x, which is a rational function, what we need to do is we need to try to see if we have vertical asymptotes, points of discontinuities, or anything along those lines. And the way that we do that is via factoring. So I'm going to factor the numerator and the denominator completely. So I get 2 times x plus 3 divided by x plus 3 times x minus 2. Now it is important right away that x cannot be equal to -3 or +2 because those two factors or corresponding factors are in the denominator. But what's also important is that we could simplify h of x and write it as 2 over x minus 2. Now I don't mind doing this, there's nothing wrong with that, but if I just told you that h of x was 2 over x minus 2, you're not going to recognize from there that there's a point of discontinuity. But it is important that we have a vertical asymptote at x equals 2, and we have a point of discontinuity at x equals -3. And if we wanted to know exactly where that point of discontinuity occurred, I could put -3 into my simplified function, and it would be at -3 comma, looks like that's going to be -2/5. And we'll see that on the graph in a minute here. Now, when they do the table of values, they are going to write h of x as 2 over x minus 3, but you'll see that they still include this restriction, that x cannot be equal to -3 or 2. And in all honesty, if you do identify it still that x can't be equal to -3, then you've kind of dealt with the fact that you've simplified it in the background and are looking at the non-simplified version as you go forward. So the graphs themselves, I don't think I hit the right one, are right here. So we see f of x is the nice big blue parabola, g of x is our red line, and then the teal, that's a little washed out admittedly, is our h of x. Now, I want to pull over this table of values because I think it is important to look at, and I'll move it in a second here, that if we look at f of x and g of x, any x value is good to go. But because f of x was the denominator, anywhere that f of x is equal to 0, which happens in 2 points, right here and right here, we see that h of x does not exist. Now, they put does not exist at -3 and undefined at 2 because -3 is the point of discontinuity, whereas 2 is a vertical asymptote. But it is important that if our denominator function is equal to 0, then our division or quotient function can't exist because we cannot divide by 0. Now, when x is -3, that's the special case of a point of discontinuity because both g of x and f of x are equal to 0, and that does mean that those factors cancel. So I'll just get that out of the way now. What we can do then is we can use our graph, let's move these guys out of the way, to identify our domain and range. And I'm going to do all three here. Well, I think it just wants h of x just because, yeah. This point, and I'll highlight it again, sorry about that. The point on f of x somewhere down here, would be very difficult to identify. So we're not going to worry too much about that. So if we're looking at h of x, we'll do domain first. X cannot be equal to -3 or +2, but other than that, x is an element of the real. And we see that on our graph that we have a vertical asymptote right here, that's at x equals 2, and we have a point of discontinuity right here. So that's my POD. All right, now for the range, this is why knowing where the point of discontinuity occurs is so important. All right, we are going to identify that due to the wonderful horizontal asymptote, the horizontal asymptote of h of x, I'll put here, horizontal asymptote is at y equals 0. And that's because the numerator is a lower degree than the denominator. So I am going to say that y cannot be equal to 0. So horizontal asymptote, but it also can't be equal to where that point of discontinuity is, which is -2/5. And other than that, y is any real number that exists. So when you go into chapter 10, you deal with quotient functions, it is very much still on the table that you might have to evaluate or justify why it can't be certain values based on points of discontinuities and asymptotes, which is chapter 9 material.